Welcome to Cast Highlight, the control tower for your application portfolio. In this demonstration, we're going to focus on the cloud maturity insights. What you see here is the home screen of the Cast Highlight user interface. Now there are two inputs that are used to capture all of the data that drive all of the dashboards and reports that you're about to see. The first one is Cast Highlight will read the code of custom applications automatically by either plugging directly into source code repositories or by automating it as part of a CI/CD toolchain. There's various options for reading the code, but that code reading all happens locally and the source code never leaves the premises. All that's produced is statistical results that are uploaded into the Cast Highlight SaaS portal. The second input is a built-in survey capability for capturing more qualitative information such as the business impact of applications or the number of developers working on an application and things of that nature. That additional context enhances the insights that come from the automatic reading of the source code and the technical characteristics of the application. Okay, so the size of the portfolio that we are going to look at in this demonstration is 232 applications, so about a medium-sized application portfolio. Now there's 4 categories of intelligence available in Cast Highlight. First, software health is looking at resiliency, agility, technical debt, and things of that nature. Second, cloud maturity, which will be the focus of this demonstration. Open source safety is looking at the open source risks associated with open source components used in a code base, such as security vulnerabilities, risky licenses, obsolete components. Essentially, it's performing software composition analysis. And finally, green impact, which is looking at the sustainability of the software based on the coding practices used in the engineering of the application. So let's focus on cloud maturity. Cloud maturity is a score in Cast Highlight that's calculated on a scale of 0 to 100. The higher the score, the more mature an application is from a cloud perspective. In other words, the more likely it is to be cloud native. The way this score is determined is, again, we're reading the source code of applications, looking inside, understanding the engineering of the applications, and identifying patterns in the code that are going to make an application more or less cloud native. So let's drill into the cloud maturity tile and go to one of our first portfolio level dashboard called the Portfolio Advisor for Cloud. Now this is a dashboard that's useful in scenarios where organizations are looking to plan a cloud migration, especially for applications that may still be on premises. Up here, we have what we call our Polymer chart, where you see each of these little bubbles representing an application in the portfolio. You'll also see those applications here represented in a table where on the horizontal axis, we have the cloud maturity score. And on the vertical axis, we have the business impact. And then down below, you'll see that what the Portfolio Advisor for Cloud is doing is it's automatically segmenting all of the applications in the portfolio into an ideal optimization path for the cloud. We could also see the full list of applications down below here. So the approach used by this Portfolio Advisor for Cloud is similar to the 5 R's methodology that's often used when planning a cloud migration. For example, we've identified 22 applications that are good candidates to rehost. Maybe these are applications that have a low business impact, very low cloud maturity, so we're not going to invest a ton of work in modernizing them for the cloud. However, we've also found 128 applications that are being identified and recommended to be refactored because maybe the cloud maturity level of these applications is a little bit higher. These are high business impact applications, and they're not going to need as much work to elevate the cloud maturity level and make them more cloud native. And then we have the other categories of re-architect, rebuild, and finally there's a category called retire. We have 5 applications where maybe the ideal recommendation here is to retire them because, again, they're probably lower on the business impact scale. They need a lot of work. The approach here is maybe they can be retired and replaced with a SaaS alternative, for example. So let's look a little bit closer on how this model works. I'm going to click on one of the segments, the re-architect segment, to help explain this a little further. And I'm going to hover over one application on the right here. And it just happens to be called Closure in this demonstration. And what you'll see pop up is a little card with some statistics on it in the middle here. I'm going to start at the bottom. You'll see the word roadblocks and the number 74. That's the number of individual occurrences or issues in the code that are reducing the cloud maturity level of this application. Removing those will elevate the cloud maturity and make this application more cloud native. Then you'll see right above that the actual cloud maturity score. It's over 60. That's a pretty good score. So if all we were looking at was the cloud maturity score, which is pretty good, and the low number of roadblocks, this would look like a really good refactor candidate because it doesn't need a lot of work. However, if we keep looking at the other scores represented here, such as the software elegance score, the software agility score, the software resiliency score. These are more health-related aspects of the software application. We see these are low scores. A quick interpretation of this is that this is an application that's probably prone to production outages. It's hard to maintain or update it, and it's written in a very complex manner. It's an unhealthy application, and that's why the Cast Highlight Portfolio Advisor for Cloud is actually recommending that this application be re-architected, not refactored, so that some of these health issues can be addressed. Some of this technical debt can be removed as part of the modernization and movement to the cloud so that it becomes optimized on the cloud in addition to just being migrated to the cloud. Now, the model that we're looking at here is completely customizable. It comes out of the box with these formulas and weightings for recommending these segments and optimization paths. But users can actually customize the model, change the formula, change the segments, the segment weights, the actual calculations to meet their specific needs. Let's take a closer look at one application. I'm going to now switch over to the refactor segment, and I'm going to select one application, in this case here, this application called Experiences. I'll see here now it's highlighted down here. If I actually wanted to manually change the recommended segment, I can do that because we know that maybe Cast Highlight isn't going to always recommend the perfect optimization path for an application, so I can manually change that. And I could also click on this little target icon to see how the score was actually calculated, and we see that refactor got the most points, and that's why that was the ultimate recommendation. But it is possible that maybe it's a candidate for other optimization paths. Okay, if I click on the name, I'm going to drill down to this specific application. Now down here at the application level, we land on what we call our Cloud Migration Advisor. So again, if this is an application that's being planned for a migration, we can choose where the application is now. So let's say maybe it's starting on premises, and then we can choose where we want to go, which of the cloud providers we want to go to, because depending on the cloud provider, there might be different cloud maturity insights available for this application. Let's start with AWS, and then I'm going to click Generate Cloud Maturity Insights. What that's going to do is populate the screen below with specific insights for this specific application. For example, it's going to identify what we call blockers. These are those patterns in the code that were referenced earlier that are reducing the cloud maturity level of this application, or making it harder to migrate, or making it less cloud native. As you can see here, each of these patterns are listed. If we find one, we count it. All the way over here on this column, we'll see what we call roadblocks, is the number of individual occurrences of each of these blockers. So if we want to look a little bit more closely at one of these, for example, this one here that's being highlighted, persistent files of performing file manipulation, that's a very common practice in an on-premise Java application, but it's not going to work well if we're trying to make this application cloud native and modernize it on the cloud. We can see here there's 157 occurrences or specific roadblocks for this pattern. If I click on that, I'll see the file location for each of those occurrences or roadblocks of performing file manipulation. In this last column, I'll actually see the estimated effort that will be required to remove all 157 of those roadblocks. So a quick interpretation of this is it's going to take about 5 person days of effort if I wanted to remove all 157 occurrences of the performance of file manipulation in the code of this application. And if I want to learn a little bit more about this specific blocker pattern, I can click on this question mark, and it takes me to the Cast Highlight knowledge base where I learn more about this particular blocker, the rationale, some advice on remediating it, and exactly how it was found in the source code of the application by technology. Now, scrolling on down a little further, because I chose AWS as my target cloud destination, I'll also see some cloud native service recommendations. These are specific AWS services that this application can take advantage of when migrated to the cloud based on the technical characteristics of the application. This is identified and recommended automatically when Cast Highlight reads the source code and detects certain types of technologies or other patterns in the code that translate and map to the application adopting these specific services on AWS, for example. I could have also checked the Using Containers checkbox, and then when I generate the Cloud Maturity Insights, it will also identify the specific blockers that I would want to take into account if I was planning to containerize this application as part of the migration to the cloud. Now, if this application is already in the cloud and it's not a migration exercise I'm going through, I could go directly to the code scan screen, which just shows me the specific patterns that are reducing the cloud maturity level of the application, or the Cloud Service Recommendations tab, and choose which cloud services based on what cloud the application is currently running on I could also go directly to the containerization insights, or if what I'm trying to do is make sure that this application can be deployed in a multi-cloud environment, I can use the multi-cloud screen to identify what might prevent or make it harder for this application to be deployed across multiple clouds. All of this information can be exported to Excel by simply clicking on this button, and it will generate an Excel file with all of these insights that I could download, push to other systems. There's also a public REST API available for integrating any of the insights you're viewing here into other systems, such as an enterprise architecture system, some other kind of CMDB, or project and portfolio management system. In addition to the REST APIs for integrating Cast Highlight insights with other systems, Cast Highlight also comes with a number of out-of-the-box extensions and plugins for other popular systems and technologies. For example, here we see the plugin installed for my Jira instance, and I could automatically pull in the Cast Highlight insights into Jira. Here's that same application we were just looking at in the Cast Highlight user interface, but now I'm viewing it in Jira, and I could see all of those cloud blockers that I was just viewing in Cast Highlight here in Jira. I could then go ahead and select which ones I want to assign to various team members or developers, create that issue, and that will get assigned as a Jira issue specifically to that team member. So in summary, what we showed is how Cast Highlight is an application control tower for your custom software that gives you insights across multiple categories, and specifically for cloud maturity, it starts by automatically analyzing the source code of your custom applications, enhancing that data with some qualitative information via built-in survey so that at the portfolio level, you could start by planning a cloud migration, getting automatic recommendations on the ideal optimization path for the cloud, then drill into a specific application, understand the specific blockers, estimate the effort required, understand how to remediate those, identify appropriate cloud-native services that the application can adopt, and then I can push that information into other systems to actually take action on, such as my Jira system that assigns tasks to my development team. Thank you for watching this demonstration.